Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for Technology, Media, and Telecom at S&P Global Market Intelligence. And today, we're going to be discussing application networking with my guest analyst, Mike Fratto. Mike, welcome to the podcast.
Thanks, Eric. Glad to be here.
Well, it's great to have you. We've been talking about various aspects of cloud and interconnect and other pieces very broadly. But application networking is really that next stage of interconnection that I guess looking to be able to integrate. But I guess before we get too far down the road, what is application networking? What's different about it?
So application networking describes the way to interconnect applications in a meaningful way. And where I'm going with this is, traditionally in networking, we were more concerned with interconnecting servers and devices and clients by IP addresses and things in the network like firewalls and load balancers and so forth. And it was very much device dependent, and this thing would talk to that thing and so forth. But with application networking, largely driven by cloud native technology, what's more important is how client software is connecting to application software. Within the application software itself, all of the different components, which would have been servers, physical server instances or virtual server instances, they're now services. And some of those may be behind a container cluster, or they may be in a SaaS location. They could be anywhere. So the network becomes, the connectivity requirements become much more fluid, much more dynamic, and we're not concerned about connecting a thing to a thing. We're concerned about how do we get this application to talk to all of its components and talk to the client. And part of that fluidity means in the application itself, means that applications and the application components can scale up and down. They can scale in and out, based on demand. Application components can move from one location or one environment to another environment. So connecting all of this stuff, that's what application networking does.
So it's taking that progression from what had been the very low-level pathways for everybody to actually increasing the level of awareness of those higher levels of application function, which, again, one of my favorite words in the podcast, availing ourselves of the power of abstraction, being able to abstract away the minutia and actually start to build interconnection based on the more important aspects of what applications need and the services and the capabilities that run on top of them.
Yeah, exactly.
So it's an area that is not only getting more research interest, but something that we think about that overall development that's been taking place of the technology, of the marketplace, of how people are actually consuming networking that's changing alongside this. And you've been shepherding a Voice of the Enterprise study about application networking. It'd be great to get some of the details of what do the studies show, what are the indications, how are people moving into application networking, and what's getting them there?
Yeah, it was a fun study to do. It was one of our Voice of the Enterprise surveys that we conducted last year. And we were focusing specifically on the adoption of application networking. So we described what application networking was, and then we asked a series of questions, just trying to understand how respondents at enterprise IT, in this case, was looking at application networking and sort of where they were in that journey from, traditional layer 4 networking all the way to what application networking does. And the first question we asked, one of the gating questions, was how many organizations, how many respondents were currently using cloud native constructs, so microservices, containers, and so forth, rather than traditional sort of monolithic applications. And what was surprising was the vast majority, 87%, were planning on using cloud native technology in the next 24 months. Currently, when we asked the question, 42% of those respondents, roughly half of those that are planning to use it, were currently using cloud native technology. So we're talking rapid growth in the adoption of cloud native technology. And it's not one thing. It's, it's, like I said, it's containers, it's microservices.
All of the different aspects that make up cloud native in its various forms.
Yeah.
Interesting. It's one of those things that to have an aspiration that's that strong to not quite double the level of adoption. But that's an indication of that level of desire to be able to move towards cloud native in some form or fashion. I mean, we all know cloud native is where all the cool kids are, but to expect to be there in a couple of years, that's a strong driver.
It is a strong driver, and I mean, it is where all the cool things are happening, but it's also there's so many benefits from cloud native technology and the application architecture and the application infrastructure that it just makes sense. And so that is driving everything else in IT, all the changes that are happening in IT, and in particular in networking. Now, let's be honest, networking has been a little bit behind the curve, a lot behind the curve in making that change. If you know, mainly because a lot of the changes that were happening that were being driven by cloud native technology were happening above the network,
Mm.
right? So it was really just as long as there was connectivity between the locations and the clusters and the servers and everything was fine. But now it's getting to the point where the dynamism of applications are driving changes in the network.
Well, the network is that place that has always been, I think, to an even greater degree than many other of the technology aspects that's out there, has been really risk averse. And as you identified, you could run things on top of it and not really have to change the underpinnings all that much. And yet, it's meant that it hasn't evolved at the same pace that others have.
Right. And that's fine. Having a static infrastructure, you kind of want that. You want the benefit of that known infrastructure that just works. And that's what the network is to a lot of people. It's there. It just connects things. And so a side effect of that is a lot of times network changes don't happen very quickly. They might happen in weeks or months between big changes in the network. And you have change control processes to go through and a whole bunch of things. Because unlike a lot of other parts of IT, if you cut yourself off from the network, you're cut off from that thing. And if you've ever managed a network, you have taken the interface down that you were working on, and then you had to go fix it, which meant going and traveling to the device that you just cut yourself off from.
It's a quote that I think was attributed to Adrian Cocroft about the risk in compute versus networking, which is that in compute, you're basically iterating a change across a small change across a large number of instances. So you're making small changes across all of your various servers and compute instances and what have you, so that the risk there is that you potentially propagate something widely, but that it's a small change and it's happening in individual instances, so that if for any one instance that's bad, it's a limited amount of the risk and the impact is relatively limited. Whereas that gets totally flipped on its inverse with networking, in which you're making small changes that in fact affect everyone who's connected to the network. To your point, so a little more sensitivity on risk is definitely warranted there.
Yeah, it's a big blast radius, and yet everything is changing. And so from that same survey, 38% of respondents said they are making daily changes to the network due to application demands.
Wow.
Yeah, that number is only going up.
And that historically, just from perspective, for the audience, daily network changes. I mean, that's again, you're messing with something that is an area that is particularly risk intolerant. But wow.
Yeah. And those same respondents, also indicated that they're seeing changes occur within minutes. 31% said within minutes. 41% said they were seeing changes occurring within hours. So this is a highly dynamic environment all of a sudden.
So I'm curious. You'd mentioned the cloud native impacts, but also the fact that cloud itself is part of that infrastructure transformation. Do you have a feel for whether or not application networking is being driven more by cloud use and the need to be able to dynamically interconnect and to connect beyond our traditional boundaries, or cloud native patterns, or a mix of both?
I think it's both, but I think it's more the cloud native patterns. So if we look at how networks have been deployed when using cloud services, in many cases, the way applications were deployed, you could think of it as a server running in a virtual machine hosted in a cloud service. And it was relatively static. It didn't move around a whole lot, and you knew where to connect to it. And the connectivity requirements were relatively simple. And so that's fine. And networking, achieved that goal and it was reliable. With cloud native, because cloud native applications are componentized and they're so dynamic, not only in, scaling out, but also in the location of where they could end up. That's really what's driving all of that change and forcing the infrastructure to become more flexible and more dynamic. Sprinkle in some DevOps on top, and you start, getting very tight integration between the application lifecycle and the infrastructure deployments. In many cases, the infrastructure is being deployed, through scripting, through some automated process driven by the developers and the manifests. And that's what's really driving all the change to application networking. So we can no longer think of static constructs like IP addresses as endpoints. We don't care about that. We care about the service name because the service name is what you want to talk to, not the IP addresses underneath it.
And it's really making that transformation, I guess, to some extent, that, hey, the move to cloud, you're now dynamically allocating resources to build infrastructure in cloud. Hopefully, those same kind of capabilities extend out to the networks that have to connect these together at the same time. Now, you use DevOps. Is this something where we're moving towards more programmatic management of networks? I mean, that, of course, it's been the same problem we've had with automating networks more broadly, which is the big concern, again, from that risk-averse community, is that automation just simply lets you do the wrong thing faster. Are we getting to a point at which there's enough trust that's been built to be able to get towards fully programmatic, API-driven networking capability? And where does that shake out?
Yeah, that's an interesting question because we've been using automation in networks for the last 20 years. Nobody thinks about it in this way. So, for example, there's three main ways that I see automation developing within networking. One way is to use an automation platform or an automation system. Basically, it's an entire environment. It's almost like a development environment geared towards network IT or IT administrators. Then you can automate workflows. You integrate in with all of your network devices and your network services, and now you can use objects on a canvas to create workflows to make deployments and changes and so on and so forth. And there's a number of these products that are in the market, and they're doing okay.
As something we would refer to as the capital P platform.
The capital P platform, yes, exactly. And they're very powerful and useful. There's the automation that comes along with like container management systems, for example, like Kubernetes. If you're working in the container world, then really most of the networking that goes on that might be of interest is all the stuff happening behind the cluster. And that's all managed by Kubernetes. In fact, network IT doesn't even have to think about that. It's simply all it cares about is how do I talk to the cluster? And everything that happens behind the cluster, load balance, security, firewall, all that stuff just happens back behind there. So there's a lot of automation going on in that area. And then the coming automation it's a broader automation than just networking, and it's more workflow oriented, but it's coming out of places like observability platforms, infrastructure monitoring platforms, help desk system and workflow and event management platforms, where those platforms are either allowing IT to create automated workflows to go out and make changes and make configuration changes, or they're handing off in an intelligent way the information and the types of commands that another system could use to integrate in with their workflow system. So a help desk or a ticketing system is an example of a workflow system that might take over and actually go out and perform actions on behalf of an operator. And there's always a human in the mix somewhere, right? We're not talking about robots gone wild. There's usually somebody going, yes, make this change.
However entertaining that might be, but
yeah. So the API-enabled network, it's definitely here. It's just now it's starting to get used more and more as more products and services develop around it. I think the idea that network IT was going to go out and write all these automation scripts, and they do that. Of course, they do it. It doesn't scale real well. In fact, I think there's a hard limit that enterprises are going to hit if they're developing their own automation scripts. And at some point, they're going to have to make that choice of, do we continue down this path, or do we go get a commercial product that's going to do this work for us?
It gets back to that question of, do you build a net DevOps team, or do you have the DevOps team leverage the network capabilities that the networking team and tools can expose to them, and who actually has to wind up doing the actual automation, the programmatic end of that? Which is, geez, it's been one of those debates we've been having in networking for ages and ages.
Yeah, and I'm a big proponent of, you've got some really talented people that really understand networking and IT, and they know how to meet the demands that are asked of them. But that doesn't mean that they have to turn around and write a bunch of code in Python. Why not use an automation platform that will take care of all of that stuff? They know that they have to go through 45 steps to add a new segment to the network. They know what they have to do, but they don't necessarily need to go in there. It should be part of their job description, I don't think. So you have to go in and write the logic to make sure that all of those steps are implemented correctly and that you've got feedback loops and controls and so forth. So use an automation platform, either one that's designated for network automation, or an IT workflow automation platform or something. So you let them make the determination of, how do we want the network to be configured and how do we want to manage the network, and then let the tool do all the hard work. You got the talent, let them do the work.
Well, it seems like one of these situations we face in tech all the time, which is that we're basically helping those teams that have the intrinsic knowledge step over the barriers to implementation, because we went through this period of saying, oh, geez, we have to get programming, we have to get networkers who understand programming, we've got to get the programmatic tools there. Now, with a lot of these integrated capabilities, in fact, their networking teams can step over that having to learn Python programming, whatever your particular language step happens to be, and get into an environment where they have abstracted tools that'll let them take the knowledge that they have and translate that into network activity and configuration changes, automation, and all the rest of that, without having to slog through the path of learning the rudiments of the programming process, and just simply take advantage of the capabilities that exist in that abstracted environment that gives them those tools.
Exactly. Exactly.
The wonder of technology. Well, but the difficulty, of course, is that it seems like it's the old problem of, then somebody's got to do the integration to be able to bind all these things together. You have to maybe commit to platforms that are going to be able to do this for you. It's, in many cases, though, the market has evolved, so it's not, way back when you could do a lot of these things if you were willing to commit to a single vendor. But now we've got environments that are, the expectation is that they're going to be multi-vendor, and have got the flexibility to pull in lots of different systems and lots of different pieces of integration.
Yes. I mean, that's the realization.
Not sensing wholesale agreement. Is that the nirvana that we are heading towards, or where are we in that journey?
So absolutely, networks are inherently multi-vendor. So you may have multiple vendors for your switching and routing network. You may have multiple vendors for your load balancing network. You may have one or more vendors for your firewalls. If you're using one or more cloud services, which most organizations do, you already know that now you've got the networking in those cloud services to manage already. So the growth in the number of networking products and services that come from different vendors is not shrinking. It is just getting much, much larger. So whatever system you want to use absolutely has to integrate and be able to manage all of those other systems. The power of APIs in the network means there's at least a common language that allows it to happen. And it also makes it easier for a network automation vendor, a software-defined networking vendor, an IT automation vendor, an observability platform, whatever that vendor is, it makes it easier for them. Those APIs make it easier for them to do all of that integration. So the decision used to be, do I go single vendor or multi-vendor and get the benefit of that vendor developed management system and all of the automation and the monitoring capabilities that came from a single vendor product, that decision now is what kind of network automation platform do I use? Or I should just say an automation platform. It could be a network focused automation platform. It could be an IT automation platform. It could be something else. So you never get away from having to make that commitment to a single vendor, but you want to have options. And that's what APIs allow is it's easier for some definition of easy. It's easier to decouple when you need to.
Yeah, and decoupling is that piece that gives you the benefits of abstraction. It seems like there are a lot of different options in terms of what enterprises can really look towards. I mean, what should organizations be thinking about in the year ahead?
So I think there's a couple. It's almost trite to say that, you need to understand and plan for your cloud native environments, but really you do. Um, and that means understanding what kinds of demands are you going to be seeing from your constituents, developers, application owners, business owners, and so forth. And those demands are things like how quickly do they need to make changes? Do they have a desire for self-service networking? So being able to go in and create a network very quickly, understanding they're not network experts. So you really wanted to make it very, very simple. So understanding what those demands are looking like, and then how can you serve them in a very simple and very efficient manner. Um, you want to start establishing a sets of goals and outcomes that are more driven around operations. So how quickly does it take to make a change in the network or to respond to a request? And those become somewhat more important than just plain old speeds and feeds. Those are important, but it's the change, the ability to make changes and to make changes reliably and quickly, sort of on demand. And then, and this is the hard part, this is the conflict, is to try to simplify as much of your network as you can. And there's, one big way to do that is to say, if you want to settle on a particular load balancer across your entire application estate, then settle on that load balancer and deploy it everywhere you can. It's at the cloud service, on premises, the edge, wherever it happens to be. At least you can gain that knowledge and the experience with that particular load balancer. You understand how it works. You're going to streamline a bunch of the work that you're doing, and you can still use it everywhere. And you're taking advantage of that, again, that power of abstraction in the infrastructure layer of being able to say, I want this everywhere.
But it does seem like we're still in that realm in which, even at that higher level, there are some trade-offs. There are different pieces of this that we're going to have to manage. Getting back to that question of, exactly how far do you let those consumers of networking capabilities go in terms of what they're able to determine, define, and demand? It's still a bunch of different pieces out there you got to juggle.
And that's what makes, keeping track of application networking and what's in the trends in networking and cloud native environments in IT so much interesting.
Well, so many different pieces, and of course, such a critical part of making everything work together well. Oh. Well, I will point our listeners to the results of the application networking study. A whole bunch more details there in terms of different views of what organizations are doing to actually leverage and get themselves to a point at which they've got more flexible, adaptable networks. And of course, to your research in figuring out how you make these trade-offs and how you make them work.
Great. We have quite a bit of content, and happy to take questions if anybody has any questions or wants to dive in deeper.
Good stuff. Well, thanks for being on the podcast, Mike. This has been great.
Thank you, Eric.
And that's it for this episode of Next in Tech. Thanks for staying with us. And thanks to our production team, including Carolyn Wright, Ethan Zimmon, and Syed Waji Abbas on the marketing and events teams, and our studio lead, Kyle Cagnolosi, Derek Brown, and Darren Rose. Join us for our next episode, where we're going to be doing a preview of the RSA conference, looking into all the various aspects of security technology that's going to be on display at RSA, and some thoughts about what's going to appear and what the impacts are going to be as we start looking at the year ahead in security. I hope you'll join us then, because there is always something next in tech.